So the next thing we're going to look at is in detail the actual methods themselves. So the first one is the wet continuous method. This is what's considered standard for aerospace, and that's why we perform it here using the test bench. And as I mentioned before, the particles are carried in a light oil bath known as a suspension vehicle, okay, or suspension fluid. So that's where the wet portion of the method name comes from. Continuous is that the bath is applied simultaneously during current application. Whether that current is being run through the part in the terms of a longitudinal current with a circular field, or that current's being run through that coil on the bench, which is a circular current that produces a longitudinal field. And so there we apply the particles while running the current. We stop applying the particles and then we shut off the current so that we don't wash them away if they've stuck to a magnetic field. There is what's called wet residual, and residual means you have run that current through or around the part. It's going to magnetize the part. You shut the current off, right? So the part has residual magnetism, and then you apply the particles to it. But the risk there is that force of the fluid flowing over the part can actually wash or displace particles that maybe had stuck to the magnetic field somewhere. So it's not typically used in aerospace because it's not as sensitive. Dry applications used more often in portable testing. You don't want to be splashing a bunch of this carrier fluid, carrier solution and particles all over. It's very messy. So doing it over a contained tank is a more ideal situation. But you can, they do have aerosol that can be used as well. Again, it's still kind of messy. Those of you that use spray paint know that, you know, you get overspray and that kind of thing. The same thing can happen here. You get this oil residue that can get everywhere. And those can be residual or continuous as well, whether you're doing it while running the current or after you've done the magnetizing current. And then the fluorescent or visible magnetic particles can be used in either one of these situations. Aerospace typically is fluorescent because it is easier to see. You get the greatest contrast in a dark environment using fluorescent particles and applying black light to them. They show up extremely bright on the dark background that is the material you're testing. So here we are applying the ferromagnetic particles while running current through the part. We've got this little hose. This is an old picture. What would be a new picture? What would be different about a new picture? What's that? They'd be wearing gloves. I recommend you wear gloves when you're doing this. The stuff will stain your hands. You won't see it until you go glow bowling. Or while you're walking around a room that has black lights in it. But it will get on your hands. It will stain your hands with a fluorescent dye. So this is being applied while magnetism is being generated. You will stop applying. There's a little trigger here to turn the flow of fluid on and off. You release the trigger and then release the button that sends current to the part or to the coil. Here is a method how we apply dry particles. So they have a yoke here. And this is that yoke I was talking about. So it's not running a current through the part, but rather generating a magnetic field. And then they call them like a little puffer ball. So there's a small amount of iron powder in there. That's the particle powder. And when you squeeze it, it does a little puff of air and sends out some of those particles. Because you don't want to dump a ton of particles on there, then those would hide, right? You just want to have just enough to kind of follow those magnetic flux lines and show you if there's a discontinuity somewhere. And so you use these little puffer balls to gently apply the fluid or the particles, also in a manner so that it's a very light kind of puff of air so it doesn't blow away the particles that are already there. Here's some of the different particles that you can get. So like I said, they come in different colors. The biggest reason for different colors is different materials you're using them on. You need to be able to have a contrast there. So if you have a dark colored material you're using them on, you're probably going to use one of the lighter powders. If you have a lighter material, something like a polished metal or something like that, you're probably going to use a particle that's a little bit darker, going to have a better contrast on it. Those are the dry powders. The powders that are used for wet methods come in bottles like this. We have, I can't remember which one we have. We have 14A or 20B, but they're bottles of powders that kind of look similar to this that are mixed in with the carrier fluid. And it's a suspension. They don't dissolve in there. You know, the particles are still particles. The fluid's still fluid. The particles don't, they don't chemically dissolve, like say dissolving salt in water. And so they have to be stirred up and kept in suspension while you're using them. When you shut our bench off in there, all the particles settle down to the bottom. And then here's an example of an aerosol particle bath, which is essentially similar carrier fluid and particles. Same thing, they're going to tend to settle inside the can, so you want to make sure you shake them up really well before you use them so those particles are distributed in the bath.